Today I will explain my first workshop in parametric future at Badr University in Cairo. It's a generative design workshop. This workshop, the first workshop about form generation, how to use parametric design in your design process and connected with your design project in the studio. First, we will learn about parametric design principles, grasshopper workflow and plugins, generative pattern and adaptive structure, from digital model to fabrication. The schedule of the workshop is 3 days. First, we will talk about parametric design as a way of design and how to use Rhino computer program, and how to generate your form in your computer. And then we will go to advanced workflow and how to make the final digital fabrication. First, my name is Dr. El-Gendy. I'm an expert in parametric design and computational design. Took different courses at different universities like East London University, about performative design and digital fabrication, and also get the best presentation in University of Berkeley in California. The first title that we gonna start with this workshop: generative skins and calligraphy museum design. We will talk about the way that we can use in the design and how it will impact your studio for design. The presentation outline: introduction, motivation, fundamental principles of parametric design. The main part of the lecture about the first part about the concepts and principles of parametric design, and the second part about form generation and parametric tool, and the final outcome in the program. First, the motivation. The motivation of this lecture about the goal is to create a system that would be flexible enough to encourage the engineer to easily consider a variety of design. This way of design helping the architect to produce different kind of design and to use the computer in the process of imagination, and help him to give different and variety of designs. There is two main parts of this lecture. The first part about the story, what the meaning of parametric design, the fundamental principles of design, parametric origins, parametric equations, computer age, Guggenheim, and Cassia. And the second part is an application part in using Rhino computer, how to produce a special form using Rhino, and how to transform this surface to the digital fabrication and using 3D printing and laser cut. We'll start with the first part: concepts and principles of parametric design. The fundamental principles of parametric design. First, what is parametric design? As we know, when you go to Google search and write parametric design and architecture, you will find an interesting way of design. You will find all these images that you can see in the photo. The visual themes, the patterns, complex form, the natural pattern of soup structure, branching structure. You will find different form and special forms of this kind of design. There's different terms of parametric design: parametric design and algorithmic design, scripting, computational design, and associative design. All these terms has the main meaning and the same meaning of parametric architecture. Here is the first definition of parametric modeling, defining the relationship between dimensions dependent upon the various parameters. The parametric design is a process based on algorithmic design. As we explained that parametric design is a process based on algorithmic thinking. Algorithmic thinking, that means mathematics. You depend on mathematic equation like x plus y equal z. You depend on different parameters and rules that together define, encode, and clarify the relationship between these parameters, so you control the design intent and the design response. Parametric design process, starting with parametric design definition and then design development and the final output depending on parameters. As I said, parameter in an equation the change in parameters change in the way of your design. The power of codes, endless range of generative power of algorithms, new environment with a system of codes. As we see in this image, you can see the changing in the angle change and give me different forms for the same surface. Okay, so you change the parameters and it's connected with the form. Computer simulation, new technique to study environment use of algorithms for generation of virtual entities. Codes and algorithms, as we see, there is different kind. When the parametric term start to use, this term is a long time started to use it from Luigi Moretti in 1960, parametric architecture. He invent and create the stadium of Luigi Moretti using the parametric design consisting of 19 parameters. As we see in this example, Luigi Moretti used the same way using the mathematical model, but it's a physical model, real model, not computational model. This stadium has versions M and N, yani M design and N design. There's different curves and the parameters depend on the angles in the M letter and N letter. As we see, this is the N model and another model for the M. This is the first one is the M, and you change the angles in the M letter. The 19 parameters change the final result of the form of the stadium. And the second one is the N design. These are different views for the versions of the stadium when he used the first angle and the big angle in the another photo. The parametric equation also, we find it in Gaudi architecture. It's an example for a parametric model in Sagrada Familia in the history of architecture in Barcelona. He used the parameters, the input parameters, equations, and output. Okay, this is the terms of parametric design. The Sagrada Familia using the parametric model for Antonio Gaudi. He used it as the upside down model of church by Antonio Gaudi. He made the upside down model of strings, weight with bird shot to create complex vaulted ceilings and arches. And then he put it upside down and then put the mirror under the big model. And he changed the string length and the load that he put. So the ceiling changed, and he get the final model for the 3D church, and the columns is like the church columns is the strings. he got very complex structure using this method and get the final result of triangle system in this model. Computer age came and the evolution of the computer from a drawing instrument to a design tool. The computer age started and the technology start everywhere, and the computer program invented different computer softwares that using the parametric model, like these softwares. The power surfacing is an application, and also CASIA, computer-aided three-dimensional design, used in Guggenheim Museum for Getty Technology. And the other software, Autodesk 3D Studio Max, you can also use these softwares in your designs, and Autodesk Maya. Grasshopper 3D and Rhino 3D, the program that we gonna talk today in our workshop, and how to use mathematics in Grasshopper and get your final design and geometry. Getty technology is very special technology. We will get an example from Frank Gehry work, the Walt Disney Concert Hall in Los Angeles, designed by Frank Gehry. It's in Los Angeles, California, this project. You will find his work is very special, using the free form structure. The Guggenheim Bilbao Museum, the second example of Frank Gehry architect, he used the same computer program, CASIA, a 3D design program which was originally developed for the industry. Each surface as an equation. He deals with each surface in these surfaces as an equation. Every single point on the surface is known with X and Y, okay, using the program design. So the structural analysis was easy for these surfaces using the computer program. There's different design schools like UCLA and SCI, ARC, and UC Berkeley and USC. All these design schools using the same way of design and the computational design. The second part of this workshop about Rhino introduction. I will give a quick explanation for Rhino introduction. First, we'll talk about the NURBS modeling and the difference between subdivision and NURBS, the uses of Rhino and industry-involved Rhino objects, Rhino interface, and Rhino geometry types. First, what is NURBS modeling? We need to understand how Rhino understand our model. The program used NURBS, the non-uniform rational-based spline. The non-uniform rational-based spline, as we see, it's a geometry depend on the NURBS or the SP line, the lines in the object. But the subdivision depend on the pixels, okay? The advantage of NURBS, smaller files, easier to model, and the model can be rendered in any resolution. This slide explains the difference between the subdivision and the NURBS. The subdivision, like Photoshop, depends on the pixels, so the model understands each pixel, so it needs to be big more. But the second image in the right, drawing with vectors, depends on the vectors on your model and the SP line and the NURBS. So if you zoom in, it will stay the same because you define the vector, not the pixels. The uses of Rhino: you can use Rhino program in modeling, rendering, animation, 3D printing, parametric design, elements analysis. The industries involved: we can use this tool in aerospace, marine, automobile, all sports equipment. You can design these objects on the program. The furniture, footwear, jewelry, you can design all this using the same program. And these are examples of renders shots from Rhino. You can also draw the pattern, like the patterns in Dubai Tower. And this is the Rhino objects. The objects in Rhino: points, you will find points, curves, surfaces, trimmed surfaces, iso curves, polysurface, solids, and mesh. First, we'll explain the Rhino interface. When you open the program of Rhino, you will find this interface. You will find first the menu, file, edit, view, curve, and the second part is the command line, and the third part is the toolbar. The toolbar that you will find the icons and the command panel. You can write your what you want to draw, and the panels consist of properties and layers, and the main viewport that you can see your model. So these are the different geometry types as we explained before. First, all these part of the introduction of the Rhino, and how to change first when you open it. First, when you open the program, you need first to change from tools and options. You need to change the unit. The units is very important, that you need to put meter if you will work with meter, or you can get your file of AutoCAD or any file using the same unit. So first you will open tools from the menu, and then options, and then click on units and then choose your units from here, units tolerance. And you can also change the way you draw inside your program, the pan, how to control pan, zoom, rotate, the mouse, how to use the mouse in your program. First, we'll open the file, and you can see the different menus from file, and you can write also here in the command panel the what you want to draw, like line, SP line, offset, any kind of order that you want to give to the program. This part about viewports, the different viewports you will find in this image, the 4 viewport that you see your model: perspective, top, front, and right. This is a projection for your model. You can see the plane that you drew your model in, and you will see this small axis X and Y and Z. Explain how to see the perspective. Also, you know how to draw in Rhino. We will open this program now. As I said, this is the menu, surface, curve, all the order that you can give, and here surface, all the kind of surface, solid, box, mesh, and also here the command panel. You can write box, so you can draw the first box. You will select here on in the viewport, and you will draw your box. Okay. And then here there is different icons that you can use in the toolbar, and this is the panel. panel layers, and you can change the panel here. From the menu you can open where you need to add in this panel, what you add in this panel. In this part we're gonna start the shell that we're gonna do in our first workshop. In the Studio 4 we took an inspiration for the studio from architect Calatrava. Santiago Calatrava's signature style that's using different structures that you can see. He's a Spanish architect. He used a design philosophy from dynamic forms and from nature, inspired from nature. His project is very, very unique. We will start with the form generation and then the form development and the final form for Santiago Calatrava. Parametric project. Parametric project using Rhino and the 3D model. We will take a simple shell today and then we will complete the form. First, the form generation. You can produce any form of these forms in your program, and then form development, and then the final stage of digital fabrication and how to finalize your work. This is the whole idea in the workshop. We will start with a simple shell. These are different examples from students' work, how to make different shells and how to produce it in digital fabrication, how to use digital fabrication, connect these. These are different examples like water drop. This shell like water drop express the moving of water, and how to produce it using Rhino, or you can use also Grasshopper for generating the form. And then these are the final result. We'll choose one of these shells and apply it in the workshop. The first shell is very simple shell. It's your first time to use Rhino, so this is the simple shell of the sound wave pavilion. You're gonna start to draw the sound wave pavilion, like the image, how to draw it, and then we'll cut it. First we will start to open the Rhino and draw a simple curve with interpolate curve. Click the interpolate curve, and you can also use it here. Click and draw your first curve, and you need also to draw another curve inside, like what we see. Okay, and then you will go to the perspective. I drew the curve in the front, and then go to the perspective, taking copy for the curve. The main curve, you can take copy and move this in the middle of the curve. How to make this simple shell? You can use this tool and then open the perspective, and then use loft command. When you click on loft, you need to put it in order 1, 2, 3 to get your final result, and you say okay. So the shell gonna be ready like what we see. Okay, if you want to add rebuild and put more lines, you can use rebuild. Okay, and you add u and v, it's x and y, 30 and 30, it's okay. You will find the grid module drawed. If you want to control this module, you can control it with point on. Okay, you can control this, and if you want to move it like this, you can also use the points on to control each point on your curve. Okay, as we see, okay, you can select these points and change what you want to change. Also, you can add anything in your surface. Okay, you can make contour on this surface like points. We'll close points on. Okay, you can make contour on your surface like this. You can add your contour lines, okay, and extrude these contour. Extrude curve. So you change your project like this into a 3D model. Okay, and that's all. After you made your contour on the surface, you can cut it as we see in this example, and you can get your surface to the digital fabrication like this. And let's see the second part of the workshop about Grasshopper and how to connect Grasshopper with Rhino next time.